Count the number of elementary steps in the mechanism. The proposed mechanism consists of 2 elementary steps. Step 1. Slow Cl plus O3 gives ClO plus O2. Step 2. Fast ClO plus O3 gives Cl plus 2O2. Because there are 2 distinct elementary steps, the reaction energy profile must have 2 activation energy barriers, 2 peaks, with a single valley in between representing the intermediate state, where the intermediate species ClO is formed. This immediately eliminates profile A, which depicts a single peak representing a one-step reaction with no intermediates. Determine if the overall reaction is exothermic or endothermic. The overall reaction enthalpy is given as delta H equals minus 285 kilojoules per mole of reaction. Because delta H is negative, the overall reaction is exothermic. In an exothermic reaction, the system releases energy, meaning the potential energy of the final products must be lower than the potential energy of the starting reactants. This eliminates profile D, which depicts an endothermic process where products are higher in energy than reactants. Compare the activation energies, EA, of the 2 steps. The rate of a reaction step is inversely related to its activation energy. The height of the barrier from the starting point of that step to the transition state peak. Step 1 is the slow step, so it must have a large activation energy. This means the first barrier, from reactants to the first peak, must be large. Step 2 is the fast step, so it must have a small activation energy. This means the second barrier, from the intermediate valley to the second peak, must be small. Identify the profile that matches all criteria. Profile B shows 2 peaks, 2 steps. The products are lower in energy than the reactants, exothermic. The first peak has a significantly larger barrier than the second peak, indicating that the first step has a larger activation energy and is the slow, rate-determining step. Therefore, profile B is the correct representation, confirming option B. The correct answer is option B, profile B.